This is functionally an application of flip-flops, and we are talking about digital device, where on this occasion I am accompanied by my college, José Gabriel Covarrubias Cobria, José de Jesús Cruz Ramírez, Leonardo Pasillas Martínez, and me, José García García. Okay. What is a flip-flop? A flip-flop is a sequential digital circuit used in electronic store a bit or information in function as a basic memory cell and has two stable states representing B, 0 and 1, or true or false. Its output change is response to input signals and is usually activated by a clock pulse. Well, we have the four principal types of flip-flop. The first is the flip-flop SR. It's the most basic and is made up of two interval NOR and NAND gates which allows one bit of information to be stored. It has two main inputs. S is set and R is reset, and two outputs, Q and its complete Q negate. If S is equal 1 and R is 0, the output Q is set to 1 set. If S is 0 and R is 1, output Q is set to 0. If S is 1 and R is 1, the state of the invariant and may cause errors in the circuit. This flip is used in basic memory registers. Now, we have the flip-flop J key. It's an evolution of the R designed to limit its invariant state. It is made up of two NAND gates and a feedback system that allows it to alternate its state when both inputs are activated. It has three inputs: J, set, K, reset, and CL key clock. If J and K is 0, the output Q is set to 1. If J is 0 and K is 1, the output Q is set to 0. It reset. If J is 0 and K is 0, the output maintains its previous state. If J is 1 and K is 1, the output Q changes state toggle with edge clock pause. This flip-flop is widely used in counters and shift registers. Now, the flip-flop D data or delay. Flip-flop D is made up of a modified flip-flop SR with a NOR gate that prevents invariant states. Its main function is to synchronize data input with a clock. It has two inputs: D data and CL key clock. When a clock pulse arises, the output Q takes the same value of D. If D is 1, the output Q is set to 1. If D is 0, the output Q is set to 0. This flip-flop is widely used in storage register and sequential circuits. Now, the flip-flop team or toggle is based on the J key, but with the G and key inputs unit into a single thing. It has two inputs, two toggle and circuit toggle. If the output maintains its previous state when t is equal to 0. If t is equal to 1, output could change state toggle with each clock pulse. It is mainly used in binary counters and frequency dividers, as it allows switching between 0 and 1 automatically.
Applications. Well, how we can use that? The flip-flops has a lot of applications. For example, could be it could work like a clock, like a memory that can keep or can store some information, uh, or also can function like a divisor of frequency. But in which objects we can see the applications of the flip-flops. The flip-flops we can find in, for example, traffic lights. We have a sequence on the lights. For example, the flip-flops can store the frequency that the lights need to follow, or the digital clocks we send information about the in which time we want to the alarm sound. Or for example, here in the TV remote controls we can apply the last topic that we saw on digital digital electronics that talks about the MOSFET, the multiplexers, and here we can find a truth table about flip-flops or logic gates. Yes, the logic gates a relationship has a relationship with these topics. Well, we are going to and now we are going to check how works the flip-flops. First, we have the flip-flop type T. As you can see, we have organized the flip-flops. Firstly, we have the flip-flop JK. First, and second one, we have the flip-flop set reset. And after that, we have the flip-flop type D. And finish, we have the flip-flop type T. Here, we have that the flip-flop type T to have a output on, we need to have the T on 0 and the clock on. And with these variables activated, we are going to have one output. We're going to check that. This one is my clock. My clock is activate, and my T in this case is this switch is off, and we have that the LED is on. And now we're going to see the type D. What happened in the type D? The truth table say that if we have 1 on my D, if the clock is activate, the output Q is going to be activate. And we have here, we have the D activate and we have the clock activate, so the Q is activate. In this case, now we are going to only activate the Q negate. The only thing that we need to change is the D. The D, it's going to be off, and the clock, it's going to be open. And now we have the other LED. And to finish, we're going to check how work the JK flip-flop and the set reset flip-flop. Firstly, set reset flip-flop. We have here that if we have the set on 0, if the reset with 1, and obviously the clock, we are going to have the letter Q, the output Q, sorry, it's going to be 0, and the output q negate, it's going to be 1. And as you can, we are going to this that is now we have the 0, the s 0, and the reset output, the input on, and the clock on. And here we have the letter q, as we can observe on the data sheet. If is the case opposite, the opposite case, we only need to do this and this one, and we have the other output that is q negate. And now we're going to observe is the same function if we have the j only that is happen. The q, it's going to be on, as we can observe on the datasheet, on the truth table. J is activate, K is 0, clock is also activate, so we are going to have the output Q in on. And the opposite case, when we have the letter K on, that is happen. Disactivate this and activate this, and we reset with the clock, and the letter Q, it's going to be that. And that's all.
Some problems that we had in this with the flip-flops were that, for example, in this flip-flop we didn't complete the logic gates. We are missing some of them, so that was a problem. Then, for example, in the flip-flop type D, I remember that we didn't connect the alimentation pins, so that was a problem because the flip-flop didn't work. And for example, and also in this flip-flop, the GK, I remember that we didn't connect it correctly because the LED was bad connected, and the inputs were also bad connected. And well, for a conclusion, we can say that the flip-flops are like sequential digital circuits that store a bit of information and change the state based on the clock. We have many types of flip-flops. We got the set reset, that is this. We have the GK, that is this. The D, that is this. And the toggle, that is this. And well, we review also the applications. We can use them in a memory, and also in a counters, in machines, or whatever system that has data synchronization. We got this information from this document. Is a presentation from the university, and this is our reference where we took out every theoretical information, we got the types of flip-flops and their connection and table true. We this document was so useful because with it we can the document lead us to achieve the practice and complete it correctly.
In the connection of the physical circuit, it's necessary to give a voltage from the deep switch, or you can use another thing, for example, buttons, push buttons. The outputs of the deep switch gives a voltage between a wire to the pins of the flip-flop, and the Q1, sorry, uh, from the flip-flop are connected, well, is connected to the LED, but using a resistor. Before of that, we need to give voltage and connect grounds to the flip-flop. And as we expect in the simulator, okay, if we if all of this is okay is done, well, okay, it means that the LED is high. Okay, if we give voltage, the LED is high.